have the same basis of this test first strategy. So this is where actually you add test before the implementation. So why this is important is when you add test before the implementation, what you are implementing is based on the test. I mean, you are implementing what should be tested, and not the other way around where you are adding test for what's being implemented. Because when you only implement what should be tested and hopefully it's in line with the requirement, then you can avoid a lot of defects, and also if there are any gaps you can identify them as early as possible. And you might know, like earlier you can identify a particular gap, it's easier and cheaper for you to fix it. So and also there's this inherent advantage of these of maintenance, because you have all these test cases where you can run through to see whether any CR have had an impact on those existing implementation. So those basic benefits are there, but I think even you are not sure of this, I think you'll realize these benefits once we go to the end of this session. So before starting off with behavior-driven development, I wanted to touch upon test-driven development also a little. The thing is, test-driven development is actually a part of behavior-driven development. I mean, in fact, the behavior-driven development is considered to be an extension of test-driven development. So we can actually discuss the test-driven development workflow with this famous red-green refactor strategy. So when we are starting off, we first add the a unit test, and you haven't done any kind of implementation. So even the method you are gonna test, you haven't created them. I mean, only when adding the test case you are thinking of how you are going to structure the code. So obviously this test case is going to fail. This is the red phase, and then you are starting to do your implementation. I mean, here the minimal implementation that's required to make this test case pass. I mean, there can be duplications in your code, there can be performance issues, but you are not going to worry about that in this phase. But once the test is passed, there's this refactor phase. Yeah, you have to think about all these aspects. I mean, you can remove all these duplications, and I mean, think about whether the code you have written have any performance impact, whether you can make things configurable instead of all these hard code values you have used, things like that. So I mean, you can do this refactoring, because I mean, as long as the test case you have added is passing, then you know you're good. So only after successfully doing the refactoring, you can move on to the other unit test. So that's the basis of TDD. But with TDD, what I have seen is, I mean, when we ask the team to practice TDD, they know what is TDD and they know its importance, but most of the time they get confused. I mean, where to start? Are we going to go from a top-down approach, or whether we are going from a bottom-up approach? I mean, what to test, what not to test, and maybe how far you can go within a particular unit test, things like that. And most often they end up practicing a TDD-like approach, which is not TDD, and it will not give you the intended benefits. For example, most of the time people tend to add an empty method with all the parameters and the return types being decided beforehand, and add the method and then write the test case. So those kind of things are not good, because in that case, anyway in your head you have the implementation in your mind, and you add in the test case to test that implementation. Then again we are going back to the other side of this cycle. So that's why it's not recommended. And also it's obvious these test cases are written from the developer's perspective, and Therefore, like if there was some kind of a miscommunication or a misunderstanding, then we have to like wait till the end of a particular development cycle to find them out. And I mean, you cannot like use these tests to like verify them with your business analyst or maybe with your product owner, because they are too technical. So that's why BDD has become a little popular. It was introduced by someone called Dan North. The concept was actually introduced like 10 years ago, but now it's popular more than ever because people have started to realize how important this is. So there's this famous quote about behavior-driven development, which says it's test-driven development practiced correctly and nothing more. That is so true. You'll see why I'm saying that. Actually, it's not me. It's by some guy called J.B. Rensberger. So if we look at how are we gonna address the issues with TDD, we have with BDD we have introduced this collaboration aspect to TDD. So what we do is we involve all these non-technical stakeholders like the product owners, quality assurance engineers, the business analyst in defining these tests. So if someone who is not familiar with BDD might think like, how are we going to involve these non-technical stakeholders in writing the test? Because they are not they are not written in some sort of a programming language. They are written in some sort of a domain-specific language. Usually, it looks like plain English, but of course, natural language, it's more ambiguous than ever. So it's natural language defined in a particular standard format with a set of keywords. So like, so it's like, given one or more context, then when a particular event occurs, what would be the outcome? So this is the format that BDD recommends recommend us to use in defining a particular scenario. So actually Dan North suggested that ideally an acceptance criteria should also be presented as form of scenarios, where a particular scenario is given one or more context. When a particular event occurs, what would be the outcome? So let's move on to, I'll come back to this. I'll see how this would we would use this with this hands-on session. But before that, I wanted to touch upon the BDD workflow. So as I mentioned earlier, like I said that BDD is an extension of TDD. So you can see like you have this red-green refactor life cycle in place, which is same as TDD, but you have this pending state in front. So with TDD, as the initial step, what we do is the technical and the non-technical stakeholders get together, discuss a feature, and write down the scenario in the standard format in English or like any other language in preference. And with that format, if you find a parser, then that becomes an executable specification. So that's the pending state. So you still haven't started with anything, and then you go into the usual red-green refactor life cycle. The thing is, in a single BDD cycle, when we are adding the code, when you see all these business logics that you have to implement, you'll realize that it's easier to implement with a couple of TDD cycles, because then it's easier for you to get things right. So with a couple of TDD cycles, you can make the failing feature file, the BDD test, to the pass status, and thereafter again you can do all this refactoring, because if this feature involves any external file access or like any database access, those are not going to be tested with TDD. Here with TDD, we are testing a particular unit which is independent from all the other dependencies. So like anyway, there's going to be some other refactoring you should be attending to. So you can work on that until the, work on that, and as long as the test pass, you are good. And that would be the end of a particular BDD cycle. So then if we look at the BDD tools, we have JBehave, which is for the JVM languages, like Java, Groovy, etc. JBehave is the one that not actually introduced with this BDD concept. And then there's Cucumber, which is the most popular one. It's more popular because it supports all sorts of different languages, Java, .NET, JavaScript, and everything. And also, of course, we have Jasmine for JavaScript. So today we are going to look at implementing BDD with Cucumber. And Gherkin is the domain-specific language Cucumber is using. With that, we are using Spock to spin off the this unit test cycle, so that you would know like how to use them in conjunction, and you'll see why it's easier. So, but one important thing to keep in mind is Spock is not a BDD tool, because for something to be a BDD tool, you need the collaboration aspect. But with Spock, what's there is, you have all the BDD principles built in. You have all these given, when, then structure in place, so that you can like use all these BDD principles in writing a unit test scenario without the collaboration part. So this is this is based on Groovy, which is a kind of another JVM language I think most of the people are familiar with. But before moving into the hand-on session, does any of you have any questions with the concepts I discussed? Was I too fast? Nope. Okay. So let's move on to the hands-on session then. Here actually I will not try to like teach Cucumber or Spock, but what I will do is I will try to implement this scenario with BDD principles using Cucumber and Spock. But you'll realize that the syntax is really easy, even though you guys are totally new into those technologies. So I picked this famous Fizz-Buzz game with a little modification, so that I could like demonstrate the BDD principles as well as the TDD principles together. So like here you can see like the format I have used. It's the suggested format of a BDD, where you have a particular scenario, and with the given context where the user is logged in, and when you start a fresh game, and when the user starts this event of playing, there can be one or more outcomes. The outcomes are like you have to output get a positive integer of size 10, and you have multiples of 3s are replaced by Fizz, and multiple of 5s are replaced by Buzz. And this have lot of other scenarios where as well, that say suppose I pick this particular scenario only for the demonstration, and so I've created this empty project. So here I'm using Gradle here because it's easier. And as for the dependencies, you can see I've added Cucumber Java it's the Cucumber library when you are using when you're trying to use Cucumber with the Java project. And of course, for other languages, there are different libraries you can use. And then you also need the Cucumber JUnit, because you will be using a JUnit runner. I'll show you what it is. And of course, I'm using Spock core to use Spock in unit testing. And this is all you need to do this. So to get started, as I mentioned earlier, I mentioned that one of the advantages with BDD is, with the other approaches, we have a specification and we try to write tests by looking at the specification. The specification is the requirement itself. But with BDD, the great thing is you can actually make the specification you discuss with the client, the test itself. So what you discuss with the client, so this is you have this feature scenario given and when then. So this is in fact your test. So I can go and create a new feature. So I'll go to the test folder, create a new features directory, and add a feature file. So you can see that IDEA identifies it as well when you use this extension .feature. So I'm just shit, there's some spaces. Sorry. Okay. So given the user is logged in and we start fresh game, then the user, I'm just removing these spaces. Sorry. So this test scenario, we are using it as a test itself. And also, even though IDEA provides us a way to run these scenarios here itself, when we are integrating it to the build pipeline, you need to have an entry point. So let me define that also first. So in the test, I'll add an integration folder. So for writing the test class, I'm using Groovy. It's basically a concise version of Java. It can pass the Java syntax too, but it's a little easier. You'll see when we start using it. So let's say. To make this class the entry point with Cucumber, what I'm gonna do is I'm gonna add the run with annotation with Cucumber. This is why actually this is actually not needed. You can also say class if you want, but it's not required. So you can see this run with annotation. It's coming from the JUnit, which comes with the Cucumber JUnit library. So what happens is when we are running this project, when the project encounters this run with annotation, it will realize, okay, we have to start executing this with Cucumber, and then it will spawn a new separate process for Cucumber, and it will execute it as in a separate process. So that's how the initiation would happen. And also you can specify all these Cucumber options here, because I have created the features in resources folder, so I have to mention that to the runner. So whereas my feature files would be, so it's in src test, resources features. Yes. So if you see, if I tries to execute this without specifying this feature option, it will say like it cannot find it's still building of it. Okay. See, it says no features found at class path integration because it directly looks at, it doesn't look at the resource folder. It looks in this Groovy source folder. So that's why I have to specify the feature path. And once you specify the feature path, you can see like undefined step exception, because so this is the feature we discussed, the text file in the standard form, and you need to like have all these steps implemented, backing up these steps as this executable feature to make it an executable feature. That's why I mentioned that in the initial discussion as well. And the great thing is when you run this in the console, it gives you all the suggestions to implement these steps. So I can simply copy this and put it to the step definition file. Actually, from IDEA also you can like create these step definitions, generate these step definitions, that this creates some weird syntax because we are in Groovy. This I prefer the approach of copying it manually. So let me create a folder. Let's say it's Fizz-Buzz steps, and I'm gonna paste it, and then of course I have to import these annotations that comes with IDO Cucumber. Okay, so you can see like it shows these pending exceptions. So like if I run it, you can say like it says step pending. That's why in the life cycle with the BDD, I show you this pending state that comes before the red state. So so when I took in all the generated steps, they might not be exactly what I need. Like with Cucumber, like whenever you get an integer, it assumes that it's a parameter. So like I can like reuse this same step definition with another integer. So that's why if I look at output a positive integer array of size 10, so you can say like this 10 is has become a parameter here. So it's the same as with this step. And if I funny thing is, if I say it like within quotes, it becomes this string also becomes a reusable with And also before that, if you could remember all these warnings where these step definitions are not implemented, once you like add these step definitions, you should see these warnings disappearing. So if you look at here, you can see like another string parameter has been introduced. So that's because we introduced this string also as a parameter. why Cucumber does this is we can reuse the same step for different scenarios. So with this, we can't like do that, but I just wanted to mention that that's there. And once I add them, you can see the warnings gets disappeared, but I actually wanted to change certain things because these are not gonna be parameters for now. So, but then I have to, yes. Right, it's fine now. Now what we're going to do is we have to like start doing the implementation. So this is so the first step where the user is logged in. I'm not gonna write that, so maybe the login code should go here, and then we have to start a fresh game. So when I have to start a fresh game, that means I need a new game instance. So but maybe I can say it like say it says game service, new game service. And people who are not familiar with Groovy, you can see that I haven't specified a type. So with Groovy, actually the types are required only during runtime. So it's really easy to use it. Therefore, so I've defined a new class. Okay, now we'll do it here. And this also has all these before and after annotations you can use. I'm not gonna go into those because it's not the intention with the session. So when we start a fresh game, I always initiate a new game service, and then the user start plays, and then the output of positive integer of size. Okay, so then we have to assign, get the result. And then we have to assert that the result is not null, and equals to, suppose this integer is array length. Yep, and then what we have to do is so like I'm simply gonna like do a dumb assertion here. So let's say so you can have instead of 3 you can have this 3 4 5 6 divisible by 3, and then we have 7 8 9 again, it's divisible by 3, and then 10, it's divisible by bus. Okay, so now I've made this a specification and executable specification. So if I go ahead and run this, so you can see like it's failing. Assignment expression is not allowed. Yes, okay, sorry. Let me rerun and see. Okay, so now it fails. Now we are in the red state. So what now we are gonna do is now we have to do the one you guys are good at doing the implementation to make this test pass. So for that, I'm gonna go to the source folder, and there service game service, and now you can import it, and then you need this play class which return the result. Let play. Um, so, uh, what it says is when you play, you need an positive integer array of size 10. So like this array length should probably be configurable, but since I'm only trying to do the minimal code for now, I'll just hard code it. I'll get back to that later, and we'll go ahead with displaying all the. Okay. Yep. And then in order to make the return type work, so I'll create this new result array. So it's nice to be the size, and we are gonna return it. And it's like an object array. And then we need is and we need some kind of logic here. If you could say like, I mean, this is not gonna work. I need to like do the replacement. So I mean, when we like encounter this kind of logics, we could see like, I mean, instead of like writing all these logic and running this feature itself, in this kind of scenarios, actually you could make use of this unit test. So like, instead of like adding these unit test just because you're supposed to, if you are try to add this unit test when when you encounter such business logics, then it's not a time waste, and also like it will help you a lot in getting the things right. Um, so um, so I say, okay, if I wanted to add some unit test, I'm gonna move it to a separate unit folder. In adding unit test, actually, it's better to follow the class path, the project structure. It says here. So I can maybe like I can create Ruby Fizz-Buzz specification. So with Spock, um, the only thing you have to do is to make it a specification. I mean, and a Spock file is to extend it with the specification. And this also use the JUnit runner. I mean, with Spock 1.0, we use they use something called Sputnik, but now with I think with this I'm using 2.0. They're actually they're just using the JUnit runner. I think this is the implementation. So now what we're gonna do is so keeping the BDD cycle aside. So now I'm trying to start this TDD cycle where I wanted to implement this Fizz-Buzz logic. So what I can do is I can start a unit test. So maybe the first scenario according to our feature is the multiple of 3s are going to be Fizz. So we can say maybe output Fizz when multiple of 3 is provided. So so with Spock, unlike unit test, you have this given when then form. That's why we say it's the BDD style unit testing. So with given you have a number divisible by 3. When you say you play with number, then output Fizz. So this is the scenario that I want to test. So I can introduce this number 3, the smallest number. This is divisible by 3 when I start from 1, and then I need an instance. Let's say, let me call it Fizz-Buzz. So so if you could see, like, I mean, when you're like writing the test, if you can decide on the structure, of course you can change it later. It will be easier. I mean, you can also like place them in these life cycle hooks, as I mean before, after, as with the Cucumber and JUnit, etc. So, but here for simplicity, I am just making it a global one. Sorry, I'm gonna say play with number, and then I'm gonna get some output, and we can assert the output is Fizz. So so you have this unit test, and if you try to run it, of course it would fail because these classes are not here. So let me create them. Oh, no, let me first move it to a package. And let me add that method. So what we need is object. We defined an object array, so we are trying to like get a single object value out of this. We are given a number, right? So let me import. It compiles, but obviously we haven't implemented logic, and if I go by the TDD rules, of course the simplest implementation would be if number equals 3, return Fizz, which can make this pass. Yes, but then since I want it for different numbers, if I go for 6 and and check. It's gonna fail. See, the condition is not satisfied, so you are going to make the correct implementation. It's something like this, like divisible by 3. This is gonna plus. Yeah, and but actually I don't want to add a separate test case for 3, so let me use a where close and add the numbers here. 3, 6, 9. You should pass all these combinations if I have implemented this correctly. Yeah, so you can see it's passing. And then similarly I need the other scenario where it should be, let me check the feature which we agreed upon, and the multiples of 5 are bus. So so you can like output this when a multiple of 5 is provided. So since I know I have to check with more than one input itself, I'll go with this when approach. So when I should have started with this number divisible by 5. So let me take 5 and 10. Play with number. Now I have these methods, so I can use them, and then output bus, and I'm gonna assert output equals to bus, right? And then let me run the test. So since we haven't implemented, we all know that it's gonna fail. So let me add that as well. So if you're gonna get bus, and maybe like you can add this kind of same scenario. I'll just copy this and to verify output the number itself when neither a multiple of 5 nor 3 is provided. So a number not divisible by 5 or 3, so we can add from that kind of numbers like 1, 2, 4, 7, 8, something like that, and play with number, even output the number itself. So the assertion would be equal to number. Yeah, so I think that's all the specification we agreed requires us to. But still we need to now unknowingly we have like implemented the logic we needed. So what we gonna do is we have to plug this in to the service class. So what we can do is just for simplicity purpose we'll just say we play with number and I'm gonna pass +1. Yep, and let me check the feature. For now I'll run it from here, but of course you can run it from the integration test entry point itself. So you can see now we have come to the green state where the tests are passing, and then you can do any other refactoring you want. I mean, so this test maybe you can add some kind of say or something like read a property file and get this. So let's say we have something like configuration loader get upper limit. So for now I'll just return 10, but this may be like loaded from file or from database, a thing like that. But then in that case, like you should realize that this kind of method they are not usually tested using unit test, because these are something that's dependent with other aspects. But once you let me make it the static one. So something like this. So you can do all the refactoring that you need to do, and as long as this feature is passing, you are good to go. Yes, and with this you'll realize that, I mean, even like when you if you get any kind of a CR, with this Fizz-Buzz game, they always say like if it's a multiple of 15, if you are supposed to get Fizz-Buzz, in such a scenario, like you can easily do the extension because you have all the test itself. So of course, if such a scenario, if you get such a requirement, we'll be discussing this feature with all these non-technical stakeholders. I mean, if they want this to be there and that has to be another scenario, then what we would say something like this, then what we can have something, and maybe multiples of both 3 and 5 Fizz-Buzz, something like that. So we can like validate these scenarios with them. And also you could see like only the last condition is appeared to be not implemented, because with Cucumber you can always reuse all these steps.